Hello everyone. In this video, we are going to discuss the solutions of the chemistry class test of Haloalkanes and Haloarenes chapter. Okay, so let's begin. Okay, so in the first question, what has been given to us is which of the following is not expected to be intermediate of the following reaction? So there's this an SN1 reaction that is taking place. And in the first step, iodine will depart. We will get this carbocation. It will further rearrange and hydride shift will take place. And this carbocation will form. And further, I minus will come and attach on this, and we'll get, okay. So water will attack because it's getting substituted. We'll get OH2 plus, and finally, so we get converted into the product. By loss of a proton. Okay. So the intermediates that are going to form with this one, a 3-degree intermediate and OH2 plus, right? So the intermediate given in option A is not going to form. So A is the correct option. If we talk about the second question, the rate of SN2 will be negligible in. We know that whenever Br will be attached on a bridgehead carbon, such as this one, this carbon will not be prone to substitution reaction. Okay? So due to that, we can say that this particular compound will not undergo SN2 easily. So C option is correct. Okay. The third question, what has been given to us is arrange the following 3 chlorides in decreasing order of towards SN1 reactivity. So there are 3 carbocations that are going to form when Cl minus departs. One is 1-degree carbocation. One is allied 2-degree carbocation. 3-degree carbocation. Dynamics will be the most stable, followed by the 2-degree one, followed by the 1-degree one. So correct option 2 greater than 3 greater than 1. Yep. But there's been given reaction of 4 bromo benzyl chloride. This is the reaction of 4 bromo benzyl. Okay. So we have 4-bromo-benzene chloride. So in this particular reaction, and reaction Cn minus, the substitution will take place on the benzylic position and not on the phenolic position. This carbon is not prone to substitution, okay, because this CBr bond has partial double bond character, right? So this Cn minus will attack on this benzylic carbon and Cl minus will depart. So what will we get? We get this compound. Br will be as it is and Cn. It will be 4-bromo benzyl cyanide. Okay. The fifth question, what is the major product of the following reaction? So we have excess of HBr we have used. So double bond here and OH on this carbon. So what will happen? There will be OH2 plus. It will depart. We'll get allyl carbocation here, on which Br minus will attach. So we'll have allyl bromide. Further, one more molecule of HBr can be added on this double bond. It will be Markovnikov addition. So what will be the product? It will be Br 1,2 dibromopropane, right? Let's see the next question. Question number 6. 4-chloro, 1-butanol, when it reacts with NaOH, what product will be formed? 4-chloro, butanol. Okay. It is reacting with NaOH. Okay. NaOH will act as a base. It will deprotonate this particular H plus. And what we'll have is O minus Cl. Now an intramolecular SN2 reaction can take place. This minus sign will attack on this carbon. Cl minus will depart. And we'll get this particular cyclic ether as our product. Okay. The name of this is tetrahydrofuran. Let's see the next question. Question number 7. Which of the following alkyl halide gives only one product, excluding stereoisomer, when undergoes E2 reaction? E2 is elimination bimolecular, right? So if we talk about the first one, it can give us two different products. It can give us, because the number of beta hydrogen present on this carbon also and this carbon also, right? When Cl is attached here, the double bond can occur here or it can occur on this carbon as well. So these are the two products that will form for A option. So A option is incorrect. B option also can give us two different forms. It can give us a double bond in this carbon, or it can give us a double bond here, right? Let's talk about the C option. C will give us, again, two different compounds can be formed. Either double bond will form here, or it will be forming on the second position where beta hydrogen is present, right? This is 3-methyl hexene cyclohexene, and this is 4-methyl cyclohexene, right? And in D option, there is only one compound. Either way you look, since it is symmetric, either double bond will form here or double bond will form on the right side. Either way, we have the same product. We have 4-methyl cyclohexene. Okay, so D option is correct. Let's look at the next question. Eighth question has, in which of the following Satsef alkene is the major product? So in the first option, there's a bad leaving group, NMe3 minus. So here, the mechanism that we'll follow will be even CB, or first conjugate base will be formed and then NMe3 will be departed. So the beta hydrogen present on the least substituted carbon will be eliminated to form the base, and then the reaction will proceed. Okay. The B option, F minus also is a bad leaving group. So that's why here also the Hoffman product will be the major product. In C option, we have a hindered base, tertiary butoxide ion. That's why also Hoffman product will be major product. Only in the D option, which is CH3, CH2, 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 C, CH3 whole twice, and Br. And when you react with alcoholic KOH or CH3O minus, this base is also not hindered, so we get the major product as the Satsef product, this one. Okay. So this will be the correct option. Okay. Let's look at the ninth question. 1,3-dibromopropane is heated with zinc dust and ether. The product form will be what? We have 1,3-dibromopropane. Okay. And when you heat it with zinc dust, what will zinc do? Zinc will abstract this two bromine atoms, and there will be a double bond. There will be a bond formation between these two carbons. So the product will be cyclopropane plus zinc bromide. Okay. The right answer will be cyclopropane. Let's look at the next question. Me2CH2NH CH2 Me. When excess of CH3I reacts, in the first step, the product that we'll get will be Me2CH2 CH2 NH. So two methyls will come and attach here. There will be plus charge, I minus. This will be the quaternary ammonium salt that forms. And now silver oxide is just acting as a base, so it will undergo even Cb elimination. Now these are the alpha carbons. This is the beta carbon. Now the carbon ion, the most stable carbon ion will be forming when beta hydrogen is eliminated. So here a 2-degree carbon ion is formed, here a 3-degree carbon ion is formed. We know that 2-degree carbon ion will be more stable. So that's why when Ag2O is reacting, this beta hydrogen will be eliminated and there will be double bond formation on this side, right? This will be the product along with a tertiary amine. And Me2. Okay. So this will be the final product. Okay. Let's look at the next question. 11th. Major product of the reaction is, we know that in E2 elimination, the beta hydrogen should be present on the anti position of the leaving group. Okay. So it is dehydrochlorination that is going to take place. Hydrogen should be present. Beta hydrogen should be present at the anti position of the leaving group. And if we have a choice between two different beta hydrogens, then the beta hydrogen, upon removal of which we are getting more stable alkene, that will be the major product, or the SATSEP product will be formed. So which is the SATSEP product? When double bond forms between these two carbons, it is triaceptured double bond we are getting, right? So this will be the correct answer. Okay, which is given in B option. In question number 12, when HCl gas is passed through propene in the presence of benzoyl peroxide, so what product will be formed? So there is propene and there is HCl peroxide. Now we know that HBr shows peroxide effect, or anti-Markovnikov addition will take place. But for HCl, there is no such peroxide effect that will take place. So simple Markovnikov addition of HCl will take place to the alkene, and we'll get 2-chloropropane as the major product. Okay, the option is correct. The next question, which of the following compounds has highest boiling point? So you're able to observe that all 4 given compounds are isomers of each other. So the molecular mass is same. So if we have to compare the boiling point, the compound with highest boiling point will have the highest molecular mass. But since all the compounds which are given are having equal molecular mass, the next thing that we have to compare is the surface area. Surface area is biggest in 1-chlorobutane. That's why the correct answer of the 13th question will be 1-chlorobutane. Okay. Let's look at the next question. What will be the product? Okay. So in the first step, what will take place? Nitration will take place. And since Cl is ortho-para-directing, you get a nitro group on the para position of Cl. Cl. Further, when NaOH is acting, nucleophilic aromatic substitution will take place. OH minus will replace Cl and we will get para-nitrophenol. After which, what we have done is this para-nitrophenol will be deprotonated also. This O minus phenoxide ion will be formed, para-nitrophenoxide. And when it acts upon CH3I, what is observed is SN2 reaction will take place. So this O minus will attack on CH3, I minus will depart, and we'll get ortho-nitro-anisole. Further, when this compound reacts with concentrated H2SO4, sulfonation will take place. So the correct answer will be this OCH3 group is orthopara-directing, nitro group is meta-directing. So on this position, one sulfonation will take place. Okay. The correct option will be this option. Okay. In the next question, which combination of reagents will bring about the following conversion? There's a conversion that is taking place between cyclohexanone and 1-bromo-2-methyl cyclohexane. So what do we have to do? We have to convert, we have to add a CH3 group, we have to remove the oxygen. We'll do it sequentially. Okay. First, let me use a Grignard reagent. So we'll get 1-methyl cyclohexanol. After which, if I carry out even elimination, I will get a double bond here. After which, if I do anti-Markovnikov addition of HBr, we get the required compound. Okay. The correct option is the first option. Okay. And the next question, we've been asked what is C. So there's 2-bromopropane upon alcoholic KOH. It will undergo elimination. So A will be propene. An anti-Markovnikov addition of HBr takes place. We get 1-bromopropane. Further, when single strand reaction is taking place, NaIA stone, then Br will be replaced by I. Okay. So the correct option will be option A. Okay. Let's look at the next question. Ethanol can be converted to propane nitrile by the following reactions. In the first reaction, what will take place? There's acid-base reaction between OH and CN. So the desired product will not be found. In HCl also same problem is there. In the second option, when it is heated with sodium, it will form ethoxide ion. When Cn minus attacks, this reaction will not take place. Okay. So what will happen is first you have to convert this OH group to Cl. How will do that? SOCl2 will get Cl. And then if we attack by KCN, we get Cn here. Okay. Let's look at the next question. Question number 18. We have methylene cyclohexane, So in the first step, what will take place? Bromonium ion will be formed. Okay. And on this bromonium ion, in the next step, water molecule will attack. And upon deprotonation, we'll get the product. PR here, OH here. Okay. And the next question, we have to correctly identify the reaction which will synthesize this compound from cyclopentane. We have to attach three bromine groups, three bromine atoms on three consecutive carbons. How do we affect that? First, we can do monobromination. What will happen? One bromine atom will come and attach. Then we can undergo elimination. And then we need bromine here also. So allylic bromination will take place through N-bromosuccinamide, NBS. We'll get PR. Further, when we add bromine and CCl4 solvent, we'll get bromine on both these carbons as well. Okay. So correct option will be C option. Okay. In question number 20, and the below given reaction, A is to CHCl3 on reaction with OH minus in aqueous solution. All three Cl atoms will be replaced by OH minus ions. Let's see H, OH, OH, OH. And then elimination of water will take place. We'll get carbon oxygen double bond and OH. Okay. Formic acid will form. Okay. Since basic medium is present, this formic acid will get deprotonated as well. Okay. HCO O minus. This will be the final product. Okay. Let's look at the next question. Question number 21. Total number of isomers of C5H11Cl are. We don't have to include the optical isomers, or the stereoisomers have to be excluded. So C5H11Cl will have how many isomers? 1 chloropentane, 2 chloropentane, 3 chloropentane, 1 chloro 3 methyl butane, 2 chloro 3 methyl butane, 2 chloro 2 methyl butane, 1 chloro 2 methyl butane, 1 chloro 2,2 dimethyl propane. These are the 8 isomers that will be formed. Okay, answer will be 8. The next question we've been asked: find the total number of possible products in the following reaction. HBr added. Okay, there will be four different products that will be formed. One will be this product, and the enantiomers of these products. Okay, these are the four products that will be formed. Question number 23. In the first part of the reaction, four moles will be used to form the alkynes on the two different carbons, triple bond on this bond and the triple bond on this bond. There are two hydrogens will be eliminated from here, and there are three hydrogens present here also. So one HBr molecule, second HBr molecule, one HBr molecule from here, one HBr molecule from here. So two HBr will be eliminated from here, two HBr will be eliminated from here, and finally we have 4 moles NH2 minus. We'll have this product, which will be buta 1,3-diene. Okay, and finally there are two acidic hydrogens present on this carbon and on this carbon, right? They will need 2 moles of NH2 minus further. Okay, so we'll get this particular di-carbon ion. And finally, when CH3 minus CH3I is reacted, this will attack on CH3, I minus will depart. This will also attack on separate molecule of CH3 and this will depart. So 2 moles of CH3I will be required. So NH2 minus 4 moles here and 2 moles here, 6 moles is required. And CH3I 2 moles are required. What is the total number of moles? A plus B is equal to 8. Okay. Question number 24. How many structurally isomeric monochlorinated products are obtained from free radical chlorination of 2,2,3,3 tetramethylbutane? So we have 2,2,3,3 tetramethylbutane. Now, how many types of hydrogens are present here? only one type of hydrogen. So it's a extremely symmetrical compound. So all the hydrogen present on each of the carbons, they represent the same type of hydrogen. So there will be only one monochlorinated product. Okay. This will be the final product that we get. Okay. Only one possible product is there. Okay. Let's see question number 25. In Finkelstein reaction, 2 grams of this compound is treated with NaI in acetone, CH3, CH2, CH2Cl, NaI in acetone will give this compound. Okay. The formula is C3H7I. What is the molecular weight of this compound? Molecular weight of this compound will be 170. Okay. So it will be 3 times 12 plus 7 times 1 plus 127. It will be 134 plus 36. It will be 170. And the next question. How many total stereoisomers are possible for the compound 2,3 dibromopentane? For 2,3 dibromopentane, it can be RR, can be RS also, can be and it can be question number 27. What is given to us is when 2-chloro-3-methyl butane is treated with alcoholic KOH, the major product is an alkene. So 2-chloro-3-methyl butane is treated with alcoholic KOH. We'll get the SATSF product. What is the number of carbon atoms which are sp2 hybridized? There's one carbon atom in this one carbon atom this one, right? There are 2 sp2 hybridized carbons. How many allylic halides are possible with the molecular formula C4H7Br? So we have double bond here, Br, double bond here, Br. These are 2. This is also allylic. Allylic means what? The bromine atom should be attached on a carbon which is next to the carbon having double bond. Okay. These are the 3 allylic bromides. Okay. Question number 29. What is the molecular weight? The main substitution product formed when ethyl chloride is treated with aqueous KCl. There's ethyl chloride and it's treated with KCN. So it will form, right? So what is the molecular weight? Molecular formula is C3H5N, right? So 3 into 12 plus 5 into 1 plus 14, right? 19 plus 36 or 55. Okay. In question number 30, we have been given how many beta hydrogen atoms are available for an E2 elimination in the molecule 1-bromo 1-methyl cyclohexane. 1-bromo 1-methyl cyclohexane. So how many beta hydrogens are there? On this carbon, there are 3. On this carbon, there are 2. On this carbon, there are 2. Right? These are beta hydrogens. How many total? Total 7 beta hydrogens are present. In question number 31, which of the following has 0 dipole moment? So we know that when it is a symmetric compound, the dipole moments align such that the total dipole moment comes out to be 0. In that case, it will be having 0 dipole moment. So if we consider the dipole moment of para-dichlorobenzene, the total dipole moment will get cancelled out, right? Net dipole moment will be 0. So correct option will be option C. Question number 32. The strength of carbon halogen bonds. We know that the overlap between 2p and 2p will be maximum. The overlap between 2p and 3p will be less than that. Overlap between 2p and 4p will be even less. And overlap between 2p and 5p will be least. Okay. So the strongest bond will be carbon fluorine bond. Carbon chlorine bond will be slightly weaker. Carbon bromine bond will be even more weaker. And carbon iodine bond will be the weakest. Okay. Correct option will be option A. Orthochlorotoluene reacts with NaNH2 in liquid ammonia to give orthotoluene and metatoluene. Okay, we have ortho. So we know that this reaction will proceed via benzyne mechanism. So we'll have CH3 further when it acts with one more molecule of NH2 minus. Will form aniline. NH2 can get added here also and on this carbon also. This is orthotoluene, and when it gets added on the second carbon, it will get metatoluene. Right? Okay. So benzyne will be formed. Correct answer will be option B. Okay. The major product obtained in the reaction. So we have a reaction in which there are 2 benzene rings. This is an activated ring, and this ring on the left is deactivated, right? Because this CO group is electron withdrawing group, whereas the CH2 group is electron donating group. Okay. So due to these electronic effects, we can say that this benzene ring will undergo electrophilic aromatic substitution. This benzene ring will not. Okay. And also, CH2 group is blocking these two carbons. These are sterically hindered. So the only substitution that will take place will be on the para position. Okay. The product will be and we can draw a benzene ring here also. On para position, we'll attach Br. Okay. Right option of 34 will be option B. Question number 35. Amongst the following halides, the one which reacts most readily with ethanol is. So the reaction that is taking place with ethanol is SN1 reaction. So you have to think about the stability of the carbocation. So whenever an electron withdrawing group is attached to the carbocation, it will destabilize it, right? And whenever electron releasing group is attached, that will stabilize the carbocation. So if you look at paramethoxy benzyl bromide, this is electron donating group, right? And when its carbocation is formed, it will stabilize this carbocation. That's why the correct option will be option C. All the other options, paranitro, parachloro, and paramethyl. Paranitro and parachloro is the activating group, whereas methyl is activating but not as strong as methoxy. Okay. So this correct option will be option C. Look at the 36th question. Total number of possible alkene obtained in the following reaction is. There's the reaction taking place. Water heat. So we have to consider even elimination, right? So first this I minus will depart. Okay. And we get a carbocation on this carbon. So immediately if the elimination takes place, we can get double bond here also and here also, right? We can get this particular alkene, which has a chiral center. Okay. So both compounds will be possible. We can get this alkene also, in which geometrical isomerism are possible. We can get cis or we can get trans also. This particular alkene may be possible, cis or trans. Further, this carbocation can get rearranged also. Okay. It can give us a 3-degree carbocation hydride shift. Right? Upon rearrangement, if then the reaction takes place, elimination of H plus takes place, then we'll get a double bond either on this carbon or in this carbon, right? How many possible alkenes are there? If double bond is here, then this is one product, one possible product. On this carbon, there is double bond. And if double bond comes here, there are two possibilities. One is cis and one is trans. The 2-ethyl can be cis or the 2-ethyl can be trans. These 2-ethyl groups, since the double bond is asymmetrical, there is a possibility of geometrical isomerism. Okay, so you have to consider everything. So these are the 6 possible isomers. Okay. Third option will be okay. We have to consider this compound twice. This methyl can be coming out of the plane also and going inside the plane also. Since it is optically active, you have to consider both plus minus compounds. So 2 here, 3, 4, 5, 6, and 7. Total 7 compounds are there. Okay, 2 plus 1 plus 1 plus 1 plus 1 plus 1. 7 different compounds. Okay. Due to this chiral center, this possible compound will be in 2 different types. There will be 2 possible alkenes of that type. In question number 37, total number of optically active isomers obtained on monohalogenation of the following compound is. We have this compound. When this carbon is chlorinated, we have 1 chiral center. Okay, so there will be 2 possible compounds. When this carbon is chlorinated, there will be no chiral center there. When this carbon is chlorinated, there will be no chiral center. When this carbon is chlorinated, let me draw that compound. When this carbon is chlorinated, there are 2 chiral centers generated. Okay, so there are 4 possible isomers. Okay, and lastly, when this carbon is chlorinated, also this one is the chiral center. Again, there will be 2 possible compounds. Total number of possible compounds will be 8. Okay, let's consider the next question. Question number 38. The major product of the reaction is okay. This is the compound. Upon hydrolysis, this carbocation will be formed, and now ring expansion can take place. Okay, so we'll have 5-member ring converting to 6-member ring, and this carbon will have plus charge. It will further rearrange, hydride shift. This 3-degree carbocation will be formed, and now water will attack. If we remove the H plus in the same step, then we can see that the product will be this one. Okay, this isopropyl will be left. There will be 2 methyls, and we have to undergo CH3 minus shift. Methyl shift will take place, and we'll get this carbocation. And upon addition of water with removal of proton, we get this particular alcohol, 1,2 dimethyl cyclohexanol, which is given in the B option. Okay, let's consider the next question. Benzene hexachloride This is the structure of benzene hexachloride. The correct option is option B. And the last question, question number 40. Which of the following mechanisms feature carbocation intermediates? We know that even elimination and SN1, they feature carbocation intermediates. Correct option will be option D. Okay. With this, we have come to an end of this discussion. Thank you.